show the difference. This is perfect because now we're going to show the contrast. Or. So and means at the same time. We want both happening at the same time, the overlapping. Or, so you go, oh wait, but what would the, not the opposite be, but what would the kind of a contrast be? Or. It's the or inequality. So the or inequality means, oh, I don't care, either or. Up to you. So you can do that, or you can do that. You go, oh, really, either? Really, I can do either? Yes. Or is way more flexible. And is like, oh, no, you must both be happening at the same time. Very specific. And is like, whoop, rule. Or, either one. So if I said to you, so give you a very weird example, to write the math contest, you must be less than grade 12 or less than grade 9. You would say, I'm sorry, one more time? Oh, to write that math contest, you can be less than grade 12 or less than grade 9. And you go, wait, what are you saying? So what am I saying? Less than grade 12 or less than grade 9. Yeah. Less than grade 12. I'm being redundant, right? So or means, oh, so you're being flexible. Oh, so less than grade 12, or less than grade 9. So or means, oh, so less than grade 12. I don't have to state two things there. So that's what we're going to do here is we're going to try to fix the statements where it doesn't have to be stated twice. I can state it twice. I don't have to state it twice. So or is very flexible. So if I said you have to be less than grade 9 or older than grade 12, you'd be like, oh, so it's so I have two separate groups that can write this contest. So or is flexible. Either or. It's kind of that idea, right? And means at the same time. So if I said to you here, x is, okay, and read it from the x. I always read it from the x. X is less than 3 or, so or is very flexible. Nice, right? So or x is greater than 9. It's two separate things. So I'm like, oh, either one? Yes, either one. I am fine with either. So you can be here or there. So that is very flexible. So this is going to be one answer. It's less than 3, so it heads to the left, or greater than 9, and it heads to the right. And your answer is both, or. Up to you, or this or that. So that's why. So it is kind of like the English language where you go or is very flexible. We, though, use and or almost interchangeably when we're talking. I can't think of a good example, but we do use it kind of interchangeably, more so than in math. In math, and is very, very specific, okay? So or is like, oh, we don't care. Less than 3 or greater than 9, up to you. Okay, just not in between, that's all. So saying there, this or that. So very flexible. Right? Or is much more flexible. We're looking for any line, where any line exists at all. So any line. Okay. Now, we do have to fix it sometimes, like my less than grade 12 and less than grade 9 scenario. You go, wait, but if you're being flexible, then we can make it a simpler statement. So here, when I think of this one, it's or, right? So or. So if I think about this one, again, I'm just going to do a little bubble on the side, and I'm going to go, okay. So if I'm going to say it's -4, so open on -4 and 7, so I do that. It's less than or equal to 7, so that means it's heading this way. So do it fast. Less than -4, so that would be heading this way. I want to know where any line exists at all. Not overlap, I don't care. Any line. So what can I conclude? Where does any line exist? Less than 7, right? I don't have to state two things. This is like my less than grade 12 and less than grade 9. It's like, well, then less than grade 12. You don't have to state it twice because they're overlapping. So I'm just saying any line at all is going to be x is less than 7. Does that make sense? So for my answer would be 7 and less. Again, and I'll tell you where you should answer on a number line versus inequality. We'll go over that in the examples. Okay, so right now we're talking theory, but that's it. So I'm like less than that or less than that. What if I said and? So switch the question. What if I said and? What would my answer be? It would, yep, less than -4, yes. right? So and is double, or is any line at all, very flexible. And sometimes or is separate, and sometimes they overlap, and you kind of go, well, there you go. So you can't memorize. I would get students who go, who would memorize or is always two separate. No, it's not. Like you can't say that it's always two separate lines, because look, these two separate lines overlap, so we just made it into one, right? People go, or is always two separate. Not quite. Yeah. Oh, sorry. Yes. Thank you. Thank you. There you go. Yeah. Right, because it's less solid. Thank you. Okay. Right. So or isn't necessarily two separate when you simplify it. Okay. Some people go memorize and go, or is always two separate. It's not quite as easy as that. Right? So we're looking at the possibilities. Okay, so now a new thing that we never did last year. So we know how to solve this. So this question's got a whole bunch of stuff. We're going to do all the little bits. It kind of discusses a whole bunch of stuff in one question. We know how to solve this easily. So it's going to solve it. And then I want to answer in set and interval. We're going to practice how I want you to answer it. And we're going to do a number line as well. We're going to verify by graphing. So we're going to do a bunch of stuff here, right, and just put it all in one example question. So first thing, solve. So for my first one, easy, we're just going to solve. So it'll be 3x minus 1 is less than 8, 3x is less than 9, x is less than 3. Okay, so we're used to solving. From now on, I always want you to do a concluding sentence. So just like in 4.1, where I asked you always to do therefore, look, and I would say, and I'd say solve, and I'd say do therefore statement. Oh, it's on the other page. So, and I'd say, okay, put a therefore x equals da, 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 and list it, right? So I want you also here to go kind of therefore and do a final answer. I don't want you leaving it like this. You should be answering in either set or interval or number line. Okay? Don't answer in all of them. See what the question's asking for. I'm asking you for set, which would be x is an element of real such that x is less than 3. So formally, interval would be this, negative infinity to 3, like that. Okay? And then I asked also for a number line. So a number line would be, and we would do 3, so open on 3, and less than, so number line. Okay, so make sure you read the question, but whenever we solve, I want you always, always to be giving a beautiful answer. Okay, so a beautiful answer, don't just leave it in no form. So it's either set or interval or number line. If I don't tell you, I prefer interval. Okay, but don't just leave it as x is less than 3 anymore. We're going to do a therefore and then answer it properly. Okay, so that's set, interval, number line. I want you to verify by graphing. So verify by graphing each side of the inequality as a function. Okay, we've never done this before, so this one's new. So what we're going to do is we're going to take this side here. So I'm going to highlight this. So this one's new. Verify by graphing each side as a function. I'm going to go back to here, and what that's asking me to do is I'm going to use the light blue. I think the light blue shows up, right? So it shows blue. So this is my left side, and then I'll do red, just a contrast. That's my right side. So I want you to use each side of the inequality. So for this part here, this is my graphing. Each side. Okay, graphing each side. I'm going to take my blue side, which is my left side, which is 3x minus 1. Oops, I don't want to do left side, sorry. I want to do y equals. So for my left side, dot, dot, y equals that. And for my right side, y equals 8. So they asked you here to graph each side of the inequality as a function. So as a linear function and as a linear function. So we know this is a horizontal line. I think we're used to that now. This one tells me that m equals 3, and this one b equals negative 1. Okay? So I want you to graph each side of the inequality as two separate functions. And I'm going to show you, we never did this before, but it's really kind of cool to see what it was that we were finding. So when we solve this inequality, 3x minus 1 is less than 8, we're actually doing 3x minus 1, which is a line. I'll do that in blue, so it's going to be y and x. I'll go by ones. Okay, so this will be y1s. So I'm doing y. I'll go by ones. Okay, and then its y-intercept is -1. The slope is 3. Up 3 over 1, up 3 over 1, up 3 over 1, like that. And then we graph this lovely thing. And this is actually y equals 3x minus 1. And then the red side is y equals 8. Y equals 8, which is 1, 2, 3, 4, 5, 6, 7, 8, which is here. Where do those two lines intersect? 3. And what's my answer from here? 3. So how does that relate? I'm not asking you where they equal each other, right? It's an inequality, not an equation. I'm asking you when, now listen to this part here. When is 3x minus 1, when is the left side less than the right side? That's what I'm asking you. So this is what you're thinking. When is the left side, this blue line, less than the right side, which is the red line? When is the blue line less than the red line? That's what this is asking. When is 3x minus 1, which is this line, below y equals 8? And when is that? Here. It's a whole bunch of numbers, not just one number. What we were doing when we solve an equation was we said 3, and we were done. And inequality is asking when is this whole thing below that. So whenever we were solving inequalities, if it's a line, we are actually comparing and finding out where these lines are below and above each other, which is kind of cool. So that's why it's everywhere here. Not just 3. Anything that side is below that red line. So that's why my answer is x is less than 3. Anything less than 3. So it's good because they kind of want you to understand what the inequality means. Yes?
So isn't that a way to check your answer as well?
Yeah, you can. As long as the graphs aren't too hard to graph. Yeah, and we're going to do a few. We're going to do an absolute, less than a parabola. We're going to find the intersection point and look at it that way. Yeah.
Okay, so why are you highlighting the 3x minus 1? Like, why don't you highlight the 8?
Yeah, you can say when is right side above this side, which is that side as well. So same thing, right? So anything to the left here. So when is this above the blue line? Anything to the left of 8, left of 3. Usually people read left to right. That's why I was highlighting that one. People just go left to right. When is the left side less than the right side? But you could also read when is the right side 8 higher than the line? And it's higher than the line, anything to the left of 3. Right? Just because people read left to right more often, yeah. Right? But it means exactly the same thing. When is the right side, which is 8, greater than this line, and it's above the line, anything to the left of 3. So anything here, that side of the graph. Right? Which is kind of cool. We never did that in grade 9 to kind of explain what we were finding with an inequality, but we're looking at kind of each function as itself. Okay, now the last part, I put all the questions into one question. I also asked you to check 2 values. I'm going to go over the proper check again. We haven't done a proper check in a while, so let's just do a proper check where you show me the steps. Usually I would say check and you just kind of sub in the numbers and go, yep, it's right. But let me show you how to do kind of a proper check if we ask for it. That way you kind of have the steps for that. Okay, so we're going to do, so this one. So check 2 values. Okay, so this is this part of the question. We're going to check 2 values. And this is, we're checking our answer, which says that x is less than 3, right? So that's my answer. So we're going to check that x is indeed less than 3 and that it works. We've already checked it here graphically, but what if we didn't have the graph, we want to check it. So We're going to do 2 checks. I'll do 2 checks. I won't always ask for 2. Might not even ask for a check, but it's good to kind of practice the skills. So we've got, when I check it, what value is less than 3 that I can check? There's an infinite number. So negative 500, negative 7.2. How about just something easy? What would you like to check? X equals, give me a number. 2. Check x equals 2. Okay, really anything less than 3. Okay, what's another one? Do you want to check 0 maybe? 0 is sometimes nice, right? Don't get fancy. Don't do something silly that you're going to make a mistake with, right? So 0, anything less than 3. So it says check 2 values to make sure you're correct. So when I check it, I always want a title. So you've got to tell me what's happening. Remember, you're trying to explain your thinking. In grade 9, we force you to do it for the marks. I'm telling you, you have to explain. It can't just be a jumble of calculations. That's not going to work, right? If you're doing a problem set, if you're doing some explanation, even when you're writing something, the easier it is to mark, the more a TA who's marking your stuff is going to be like, yeah, good, like that. If they're looking at your stuff going, what are you writing? They're going to find more mistakes and they're going to take off more marks. You kind of want it to flow, right? It's like, oh, good, pretty good, like that, right? So easier it is to mark. I find that it was faster. I had one student when I was in university, which was 5,000 years ago. He wrote as small as possible because he was hoping they wouldn't find his mistakes. That is not a good alternative. How about you write neatly with good steps, and then you won't. That's a better approach. Needless to say, he did not survive long in the program. So, yeah. So that was one approach. We're not going to use that approach. Writing small so you don't find your mistakes was not a good approach. So, anywho, we're going to try to write neatly with process, right? And then they kind of go, yes, good, you got the right thought process. So we're going to do this. So when I take this, I want you to take the left side of the original. So check in the original. Okay, original. So always check your answer in your original. I don't want you to check it right in your second step. Okay? And I want a proper steps, please. Proper steps. I don't want it to be just, oh, I checked it on my own. There's my rough work. It works, right? If I ask you to show a check, right? If we ask you to show a check, then we want to see the proper check, like a proper check. If you're checking it for yourself, I don't care. Just do rough steps, right? Don't waste your time. But if you're asked for this steps, I need this. So you're showing me I'm grabbing the original 3x minus 1. So grab the original, the typed out question, not the second step. Don't go 3x. Don't go, oh, I took the second step. That's your answer. Take my original typed out one, right? So you're checking in the original. Then you just sub in. It's easy, right? So I'm just pointing out kind of the little things that people forget. So you go 3, sub in the 2, minus 1, 6 minus 1 is 5. My right side, so please state it. So tell me, my right side is actually just 8. So you're just telling me what I already know. But you're kind of doing a formal, I found my left side. My right side was 8. You can say since the right side is 8 or whatever, right? I'll just say right side is 8. I have nowhere to sub in, right? So I'm just going to do that. Now, what's my conclusion? What I'm looking for is that I want my left side to be less than my right side, right? For my original. So then is my left side less than my right side, right? My left side is less than my right side. Right? So then that means it's still valid, it's still true. So I would usually say, therefore, true. Right? So what we did in grade 9 is we would say left side equals right side, therefore true, or therefore it's my solution, but we don't say, we say left side less than. Right? So as long as that's right, check it again, and we're going to go take again my left side. I know it's a pain to write, but still write the proper step. Usually we wouldn't ask you 2 of these anyway, so we're going to go 3 times 0 minus 1, and 0 minus 1, so negative 1. Again, you're just proving it. Actually, I should have asked you to prove that it doesn't work, right? So choose one that doesn't work. So here we're going to say again, my left side is indeed less than my right side, this therefore true. I'm going to change this question for next time and say prove one that is true and one that isn't. So what you'll get is that the left side is greater than the right side, then you'll say therefore not true. Make sense? Yeah.
If it had like an equal to sign as well.
Yes. It could actually be 5 equals 5 or 8 equals 8. Yes. So if it was an equal sign, good question. If it was equal, less than, or equal, so if the original question was less than or equal, I could get an 8 with an 8, and you would say left side equals right side, therefore true. And there, in that case, you would say, yes, left side equals right side, therefore true, because of the original, yeah, so exactly, good. Right, so it could be equal, good point, if the original question had the less than or equal sign. Anything else?